In this video, I'll be covering my extractor machines, the ducting, how I connected up all of my tools, and installing a pillar to the center of my workshop from which to run services. I've added timestamps to the description box below and on screen now if you want to skip to the bits that you're interested in. And I'll have separate videos covering how I made my blast gates and my dust cyclone. Starting with the extractors themselves, I'm going to be using two extractors and I'll explain why. The main one I'll be using is the one I've had for a few years now. It's the pneumatic NVD 750 with the HEPA M-Class filtration unit. I've already talked about it in detail in a previous video, so I'll link to that in the description box if you're interested. That is connected up to a large cyclone dust separator, and from there the cyclone is connected up to my table saw, my miter saw, my belt and disc sander. I'll also be using it for my hand operated power tools like my track saw, circular saw and sanders, and I'll be able to vacuum the floor and my workbench with it whenever I need to. Now, I had hoped to use the pneumatic and cyclone for all of my extraction needs, but I'm going to be using some 68mm diameter pipe, and that's going into a 50mm diameter cyclone, and one of my tools really needs to be connected up to a larger 100mm diameter duct to deal with the large amount of chips that it kicks out very quickly, and that machine is my planer thicknesser. So for that reason, I've bought a separate extractor just to serve that tool alone. The one I opted to buy is the Record Power DX1000, although it's worth pointing out that that machine is exactly the same as the cheaper Charnwood DC50, which retails at around £119, and the even cheaper Rutland's DK7109, which retails at around £89. They are all the same machines as far as I can work out, which no doubt come from the same factory, they've just been badged differently. All of them have the same specs. There are two reasons why I went for the Record Power. Firstly, I wanted to buy from Amazon because I had some affiliate money saved up on my account there. And secondly, at the time I was looking, there was a customer returned one listed via Amazon Warehouse Deals that had a damaged box. So it was on sale at £108. And also it's green, so at least it'll blend in nicely with my miter station. I did initially look at some larger capacity chip extractor options like the Metabo SPA 1200 with its 65 litre capacity and the Charnwood W685P with its 60 litre capacity, but ultimately I wanted something that was going to fit underneath the central unit of my miter station. The DX1000 only has a 45 litre capacity, so I'll need to empty it more frequently, but that's a sacrifice I'm happy to make because it'll tuck away nicely and take up less space. For the ducting, I predominantly used 68mm PVC downpipe, which is supposed to be used for guttering applications. There are some good and bad points about using this, and I'll cover those later in the video. In my previous workshop, I used 40mm waste pipe because my workshop was much smaller and that worked great, but I did occasionally have blockages, so I think 68mm is going to be much better. First of all, I added a quick corner shelf so that I could position the extractor right where I wanted it in relation to the cyclone. And I mainly did that because I wanted the flexible hose run that goes to the cyclone to be as short as possible. And that's because solid pipe works much better for airflow than the flexible stuff. The hose I'm using here actually came with my extractor, and I only needed a short bit of the hose, so I cut it to length with a knife and wire cutters. To connect that hose up to the 50mm cyclone, I bought this, a 90mm to 51mm silicone reducer from eBay. You can get these in all sorts of different sizes and they're usually between £8 and £12 each. I was expecting to need to use some gaffer tape here, but actually I found I could squeeze and manoeuvre it inside the flexible pipe and it was a really nice fit. The other end also fitted really nicely onto the cyclone. Next I needed to adapt from the 50mm cyclone inlet to the 68mm PVC pipe, and for that I got another eBay silicone reducer, this time a 70mm to 51mm one. And that also happened to be a really good fit, but I am also going to be using some Jubilee clamps with these adapters just to make sure that no air can leak out. The PVC pipe could just be cut to length using a hacksaw. I have used my miter saw to cut PVC pipe in the past, but that kicked out loads of static charged plastic shavings all over the workshop, which was really annoying, so I stuck with the hacksaw this time, and I followed up with a knife just to clean up the rough cut edges. The fixtures that are available for 68mm PVC pipe are pretty limited, to be honest. I got some of the 67.5 degree branches and some 112.5 degree bends, plus the clips that are designed to hold the pipe to the wall. You can also buy 92.5 degree bends, but that steep angle of bend isn't going to be ideal for airflow, so I didn't bother buying any of those. Much better off using the more subtle bends like the 112.5 degree ones. The main issue with using 68mm pipe for dust extraction is that unlike the push fit waste pipe I used in the past, this stuff doesn't seal together. The fittings are all pretty loose. So to fit the pipe to the fixtures and create an airtight seal, I wanted something that was going to be easily removable and non-permanent, so that ruled out glue or any kind of adhesives as an option. The best option I came up with was to use a trick which I found out about through one of Peter Millard's 10-minute workshop videos, a great channel which I'll link to below in the description box if you're not already familiar with it. And that is to use bicycle inner tube. I managed to find some of this Nutrac 27.5 inch long, 2.5 to 3 inch diameter inner tube. 68mm is 2.677 inches, so it sounded like it might be perfect, so I took a punt and bought a few on eBay. And they fitted over the pipe really tightly, so tightly in fact that there was no need to use Jubilee clips in addition to the inner tube, so this was going to work really well. Now I'll be totally honest, fitting it to the pipe is a bit tricky and that makes it quite time consuming, so if you're looking for a quick and easy solution then this may not be it. But the way I see it, once this is all set up, I'll probably never have to touch it again. So a bit of short-term pain now for a long-term gain is worthwhile, and it does seal everything really well. Also, like with anything, the more you do something, the better and quicker you get at it. I found that the best technique was to use a scrap of wood with a 68mm hole drilled through it, and then I used my body weight to push the pipe against the workbench to hold it in place, and that made things much easier. This first run of pipes is to serve the miter saw and my disc and belt sander which sits beneath the miter station. I cut a piece of pipe at an angle and then I could mark up a shape that I'd need to cut out in order to push the pipe through the top of my miter station cabinet. I could then drill a series of holes holding the drill bit roughly at the angle I wanted, and then I removed most of the waste using some auger bits. I could then come back with a rasp to refine the shape, and eventually I got the pipe to fit through there really nicely. I could then add pipe to where I wanted it and add one of my blast gates. I already had lots of different vacuum connectors and hoses from my old workshop, and for this machine I decided I'd make use of what I had. I found some fittings that fitted onto a hose to go straight into the machine, no problem. But at the other end I didn't have anything large enough to connect to the 68mm pipe. So I took the largest fitting I could find, mixed up some epoxy and then smothered a piece of string into the adhesive. I could then wrap that string around the fitting, wait for it to set, and then I wrapped it in gaffer tape. That fitting then screwed directly onto the vacuum hose and it then fitted nice and snugly inside the pipe. To hook up the miter saw I added another blast gate, and then I needed to cut a hole through the hood at my miter station, so I used my 68mm hole saw to cut a hole for the pipe to fit through. I bought some 50mm flexible hose to connect up the miter saw, but the fittings that came with it were too big to fit the outlet of the saw. Fortunately though, I found another fitting that I already had which fitted nicely, and that fitted the new hose too, but I did use another Jubilee clip just to make sure it had a good seal. For the other end of the hose I found another fitting, but it was a little loose, so I added a Jubilee clip again, and then I used hot glue to add a piece of pipe to the inside to seal any gaps, and then I wrapped that in gaffer tape too, and then I could connect it to the 68mm pipe using another 68mm angled fitting. The second of my pipe runs needed to go up and over to the centre of the workshop via the ceiling, so I secured it to the side of one of my metal cabinets with some nuts and bolts. Mounting it to the ceiling was a bit tricky on my own, so I got Ria to lend an extra pair of hands while I secured it in place. And this one basically goes up to the ceiling and then avoids all of my light fittings, and then it comes down to serve the middle of the workshop for the table saw. And I also added a couple of other blast gates here, and I'll talk about what I'll be using those for a little bit later in the video. This pipe here that goes down to the floor, I've mainly just installed to hold up the weight of these pipes, which are currently suspended just from the ceiling at the moment. and I'm going to need to reinforce this, so I'm going to go and buy a 4x4 timber to install. So I got this 4x4 from my local timber merchant. The cost was about £12 and it's a 3 metre length. Aside from this being useful for mounting my dust extraction pipes to, it'll also be used for running power to the centre of the workshop. I can run power into the loft space and down to it so that I don't have to have a trailing power cable to the table saw, which is what I'm currently doing. This pillar was rough sawn, so I went over it with my electric hand plane to clean it up. And then I added a round over to the edges using my router. The pipe mount connectors were too wide to fit onto the 4x4, so I went and found another piece of timber to mount onto one side, and I found this 2x2. So that got glued and secured with screws, and then I wanted to round over the edges of that piece too, but as I was doing it, the bearing flew off the router bit, which kind of messed up the cut, but I'm glad it happened here rather than on some important commission. I didn't have another roundover bit, so I reverted to a spoke shave and block plane to finish up. Next I measured the ceiling height using my laser measure, and then I added another 120mm for reasons which will become apparent shortly, and then I could cut the pillar to length using my circular saw and a speed square guiding the cut. I marked up where I wanted the pillar to be situated onto the ceiling, and then I drilled a hole up through the ceiling, and then I ventured up into the loft where I could lift the insulation to find that hole. Using the offcut of the 4x4, I marked up the square that I wanted to cut away, and I did that by drilling a few holes and then using my multi-tool. I could then bring the pillar in, offer it up to the ceiling at an angle, and then try and feed it through the hole. And from up above, I filled the space between the joists and the pillar using a piece of timber, and then I drilled pilot holes through the pillar, the spacer and the joist. And from up in the loft, you can see where that extra 120mm to the length of the pillar comes in useful, because now I can secure it to the joist. I needed to temporarily lift the floorboards to get access to add the washers and bolts at the other end. I then spent some time making sure that the pillar was plumb using my spirit level, and once it was, I marked around the bottom of my pillar with a marker pen. I then cut a simple mitered frame from some 2x3s that I can mount onto the floor around the pillar. I used my SDS drill to drill into the concrete and then secured with concrete screws. I could then secure the pipes onto the pillar. Another use I found for the pillar was to run my air compressor hose alongside the dust pipes, and I connected it using a few cable ties. That means my air hose is going to come from above, which means it won't get snagged on things or drag around on the floor while I use it, and it's going to be right in the middle of the workshop where I need it. I made a simple hook using some 20mm conduit from which to hang the hose to keep it out of the way. To hook up the table saw, I bought some of this 63mm diameter hose from eBay, and this was the perfect size to fit the dust port on the machine. It also fitted over the angled pipe fittings really nicely, and again I used more Jubilee clips to attach them. Just in case you're wondering why there's been no mention of dust collection at the bandsaw in this video, that's because I've never really found dust collection to be that effective on a bandsaw. So I just tend to rely on the passive dust collection drawer which is built into my machine. I know there are some effective solutions out there. I've seen the videos on YouTube. All of those mount directly underneath the table where the blade exits the cut, and I might do something like that in future, but that's for another day. Below the blast gate for the table saw, I added two more. One of them I'm going to use for hooking up to tools like my circular saw, track saw, random orbit sanders and routers. And the bottom one I'm actually going to use to vacuum the floor, and I can also use these different attachments to vacuum dust off my workbench and things like that. I also had one of my mates over who is an electrician to set up the extractor to run on a remote control, just like I had before at the old workshop. I have two of these remotes, and I put one at the table saw and one over at the miter saw so that they are always within reach when I need them. I wasn't sure how good the suction would be because the pipe run is actually quite long, but actually it's really good. In fact, it's even better than the suction on my old system, which had a shorter pipe run. And I don't know loads about this sort of thing, but I guess it could be A, because I kept flexible pipe to an absolute minimum, opting for solid pipe for the long runs, which apparently is best for airflow, and B, maybe because of the bigger diameter pipe. I don't know, but one thing's for sure, the suction is really effective, so no concerns there. In terms of using 68mm diameter pipe and whether it's a good option for other people, there are some good things about using it and some bad things. First, the good, it's inexpensive compared with other ducting options. I paid about £60 for everything. In comparison, the dust pipe kits available from the likes of Rutland's and Axminster retail at well over £100, and they don't even have enough of the specific components I needed to set up my system. It's solid pipe and it's smooth, which makes it really effective in terms of air resistance in comparison to flexible ducting. The 68mm diameter is a really nice size. In the past I used 40mm pipe and I did have a couple of blockages over the years, so I'm confident that 68mm is going to be a big improvement and it should easily deal with any of the dust that my machines create. The bad, there are risks associated with static buildup in PVC pipes and some people recommend grounding it. There's a good video by Marius Hornberger about that, which I'll link to below if you're interested in checking that out. However, having done some research on it and having used 40mm PVC pipe in my previous workshop for a few years, it's not something I'm concerned about, but please do your own research if you're considering using PVC. It's not transparent, so if you were to get a blockage, you won't see where it is, but that's not an issue for me because, like I say, I don't think I'll get any blockages because I'm only going to be using the system for dust and small shavings. Thirdly, and perhaps the biggest issue is, as I mentioned earlier in the video, the 68mm pipe doesn't seal, unlike the 40mm push fit pipe I used in my old workshop, which had rubber O-rings inside each fitting that creates a really good seal but could also be easily pulled apart and pushed back together again. So you can either do what I did with the inner tube, or you could glue it all together and hope that you never get a blockage, or you can just use it as is and hope that the air leakage isn't a problem, but I expect it would really let you down in terms of suction, unless perhaps your pipe runs are much smaller than mine and you only need a few fittings to set it up with your machines. You could of course just use gaffer tape to seal up the gaps, that's another option, but I'm pretty happy I went with the inner tube option, even though it took quite a lot of time to fit. So I'm really confident that this is going to work really well for me. I hope you enjoyed the video. Let me know in the comments what you would have done differently. I am quite interested in this stuff. If you'd like to receive early access to my videos, free project plans and cut lists, and a name credit at the end of my videos, you can support the channel on Patreon and there'll be a link to my page in the description box below. Thanks for watching.